Okay, so Margaret, from your point of view, which role can carbon dioxide removal technologies play in climate stabilization, and how do you believe that CDR technology deployment may affect the future of international climate policies?
So carbon dioxide removal by terrestrial ecosystems can either be through soil or carbon sequestration, or through bioenergy combined with capture and storage. If we start with sequestration first, there are estimates that it can sequester, on the generous estimate of, say, 2 gigatons a year of carbon, and you may get other estimates, but this is one. So this makes it a substantial fraction of current fossil emissions, 20%, 25% of emissions. And it has many co-benefits. So if you enhance soil carbon sequestration through changes in management of, say, managed cropland, that means you're building up soil carbon, so you're building up soil fertility. So it has the co-benefit of enhancing soil structure and soil fertility. And in that way, it can be part of an international agreement if there are price supports for countries that have a lot of degraded soil or poor fertility soil, getting a little extra money for better management. So if they can prevent erosion or reduce the amount of tillage, use cover crops, anything that supports sequestration in that way has that co-benefit of building up fertility. And this can be a way of, in a development sense, of transferring support.
And what about negative externalities?
So the negative externalities from sequestration come when it is done in a way that either adds pollution to the environment or reduces habitat quality. So if you grow a monoculture plantation forest for sequestration, then you have actually lost a lot of habitat value. You're growing a fast-growing tree maybe, or you've planted a eucalyptus. It may not, so it may even be a non-native species. So this is an almost complete loss of habitat value. Or if you use nitrogen fertilizer as a way to increase productivity and increase sequestration, then there are costs with carbon costs to producing the nitrogen, but more importantly, there's a lot of downstream pollution from adding nitrogen fertilizer. So this is negative costs. Finally, if we manage land for sequestration, it means we're locking up carbon, and usually, or often, the carbon flows would otherwise be used for some other good, some other human need. And so you could be taking that away from people. If you lock up a forest that had mixed use in a place where people relied on some of the forest for fuel wood, let's say, and you take that away, then there could be some
So there may
suffering.
be some implications for equity,
yes,
particularly between north and south and poorer regions. Do you believe that the current governance frameworks of climate policies is able to take these potential inequalities into account, or distortionary effects?
Yeah, I'm sure it's not. But it's also because of differences in land control within a country. If the government at the high level or provincial level has an incentive to lock up the land in a way that isn't taking into account the local use, I think that's where you also have problems. And in most countries, there's some. So, and then for bioenergy and carbon sequestration, there are additional risks because then you are certainly converting habitat. So you certainly have a land use change. You are either greatly cutting the forest on a fast rotation or growing a grass crop. So you perhaps have introduced species, you've lost habitat value, and so you have all the same, and if you have fertilizer, all the same problems as with sequestration. And in addition, you're harvesting nutrients away, so you may end up with nutrient depletion. And you have a double carbon benefit, because maybe you're offsetting the use of fossil fuels for energy, and if you capture the CO2. So as opposed to just being neutral for biofuels at best, this case you are carbon negative.
So in your view, what is the state of play in biocarbon science?
Yeah.
Where are the gaps where research should be directed to?
Well, that's a good question. I think we have, for really, say 3 kinds of research. If I could plan a research agenda, it would have 3 pieces. The first is to understand simply how much sustainable CDR could we have? What are the ecological limits in terms of available nutrients, water, and land? And especially, research has not been done on available nutrients, and I think even on water. We understand the role water plays, but we don't really know where there's enough water and where there are other needs, and where increasing primary productivity would steal water from water supply or groundwater. The other issue would be to understand better the ecological impacts, how one could place CDR on the land with minimum impact. And then finally, at scale. So if one says, if we only want 1 gigaton a year, what are the options? If we want 2 gigatons a year of carbon, what are the options? And really, where are the best options if we look at the real landscape? Not ecological theory, but where should we really do this? That's research too.
Good. And do you believe that terrestrial sequestration options will play a role in future climate agreements, policies, and hopefully agreements?
Yes, and I'll take a chance to add a 4th agenda item, which we did talk about, which was if you have large-scale land use change, that land use itself has effects on climate through changes in albedo and evapotranspiration. And these can be big climate effects, and we need to know what they are. So in terms of, you were asking about, will it play a role?
Yeah, will it play a role?
Well, there's so many, I think so, because...
In the short run, on the way to Durban.
So it already is. Because already no-till agriculture is considered a soil carbon sequestration measure that is inventoried in the UNFCCC, the UNFCCC method for estimating the carbon sequestration, and where people are considering markets, this is already included. So this is one example. And then RED, the reduction of forest degradation and deforestation, is already in the discussion in such a big way. So, yes.
Okay, good.
Yeah.
Good, Margaret.
Thanks
a lot. It was not so long.
No, you were very efficient. I appreciate it.